Huh? So I'm going to do a partial fraction. 1 over x squared minus 25 is what? What's the correct partial fraction for this? A over x minus 5 plus b over? Who will tell me what a is and what b is? I don't have time for that. What's a? What is b? What did you get for a? So negative 110 here. And here?
110.
110. So I would say this is equal to 110. 1 over x plus 5 minus 1 over x minus 5. Is that what you have? So I will use this as in the integrand. And what is the antiderivative of this? ln x is 5. And the antiderivative of this? Negative ln x minus 5. We will evaluate this at a, evaluate it at 6, and then let a go to infinity. Huh? Evaluate it at a, evaluate it at 6, and then you let a go to infinity. I would combine the logarithms here. Issue some properties of logarithms. You know how to break calculus? ln of what?
X.
X plus 5 over x minus 5. Evaluate that at a, evaluate it at 6, and subtract, and then let a go to infinity. So I will evaluate it at a, what do I get? And then evaluate it at 6, and what do I evaluate it at a, what do we get?
8 ln of 8 plus 5 over ln or over 8 minus 9.
Okay. ln of 8 plus 5. ln of 8 minus 5. And here, what do we get?
ln
1 of 11 over.
over 1. Wait, yeah.
And then we're going to let a go to? We'll let a go to infinity. Okay. Now, well, this one's not going to be anything. It's not going to change. What's this one? As a goes to infinity, what does ln of 8 plus 5 over a minus 5 go to?
0.
You think? Why?
Because you plug in infinity over infinity. I mean, if you had like infinity over infinity.
Well, if infinity over infinity is a dangerous thing, then you have to use L'Hopital. Okay, I'm sorry. Who's to say infinity over infinity is 1? Who's to say infinity over infinity is not 2/3? Who's to say infinity over infinity is not infinity?
I mean, I was just thinking like because a doesn't have any degrees. You know, like when you protect with that rule. I mean, they go by
We
coefficient.
realize this is a rational function. If you want, you can change this to x. The limit as x goes to infinity of ln x plus 5 over x minus 5. Same thing, yes? X plus 5 over x minus 5 goes to what as x goes to infinity?
1.
Right, it's a rational function. Degree of this is what?
1.
Degree of this is what? So you take the leading coefficients. What's the leading coefficient here?
1.
What's the leading coefficient here?
1.
So this goes to ln of?
1.
ln of 1.
Which is 0.
Today at 9:45, infinity over infinity was 1. At 9:50, maybe 2/3. And now we let. So this is minus
Yeah, so only the 1 over 11.
minus ln of 11.
Over 10.
Oh, over 10. Over 10. I'll stick with 110. Negative ln of 11. Convergent. 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 Okay. Let us look now at the second type of improper integral, where we're integrating and the integrand becomes undefined over the integral. So something like this. And why is this improper? Because you're integrating from 0 to 1, and at x equal to 0, 1 over x squared is undefined. So it's not improper because of this. It's improper, I mean, infinite limits here. It's improper because when x is 0, this becomes undefined. So if you graph this function 1 over x squared, it looks like that. Then you're integrating from 0 to 1. So how do we break this up using limits? We say we'll approach the 0 from the right. What do we write here?
Avoid the axis.
Limit as a approaches 0 from the
Right.
what's my integrands? My bound. Right. Clear. So now I have to work out this antiderivative. Evaluated at 1, evaluated at a, obtain a function of a. On that function, let a approach 0 from the right. Well, what is the antiderivative of this thing?
Negative 1 over x.
Negative 1 over x. Evaluated at
1.
1, evaluated at,
Right.
and then obtain a function of a. On that function, let a approach 0 from the right. So we need to evaluate this at 1 and 8. What's the what do you obtain when you evaluate this at 1? Negative 1. And when you evaluate this at a and you subtract? Negative, you subtract negative 1 over. And you are going to do what? You're going to do what?
Plug in.
You're going to let a go to 0 from the right on that thing. Well, this is going to be what? And as a approaches 0 over here, what do you get?
Infinity or negative infinity.
And negative infinity times negative infinity plus infinity. So this is the divergent. That is to say, this area here is what? This area here is what? Infinite. This area is finite, but this one is infinite. Okay, you try it. Try it.